Okay, good evening all. So today, from last few lectures, we are discussing related to the destructive testing method and non-destructive testing methods. And in previous lecture, we have concluded tensile testing and impact testing. Now, in today's lecture, we are going to discuss a few points related to the creep test, how this creep test is conducted, and which points we are going to discuss in today's lecture. First, we'll start with the purpose of conducting this creep test, why we are conducting this creep test, and after that, its experimental setup or experimental arrangement, then its procedure, and after that, we will discuss related to the some factors affecting the whichever creep limit is there or creep strength is there, or you can say that the creep rate is one term is involved in this creep test, which factors will affect that creep rate or creep curve, what are the various areas in the creep curve, and after that we will discuss how means which type of cracks or fracture will occur in this creep testing, or you can say that what are the types of the fractures in this creep test. Okay, these all points we are going to discuss in today's session, or in this today's lecture, you can say that. Then creep test, first we will start with why we are performing the creep test, or first initially we will start with what is the meaning of creep. Okay, what is the actual meaning of creep? Now, what is the meaning of the creep? Creep is nothing but, you can say creep is nothing but the deformation. Now, this deformation is at a very slow rate. Okay, it is deformation which is very slow and which is progressive in nature. As time is passing away, deformation is increasing in that particular material. Okay, that will be termed as the creep, but here some specific conditions are there. Whichever deformation is occurring with the time, it should occur at a constant stress and at a constant temperature. That will be termed as the creep. Okay, I will repeat it again. What is the meaning of the creep? The deformation, you can say that, in other words, the change in the length occurring in that particular specimen, or you can say simply change in the length, or slow and progressive deformation which is occurring in the material with time. Okay, with time, here our variables, we are taking the reading of this deformation against the time, and we are keeping the values of stress and temperature constant. Okay, whichever deformation is occurring in the material against time at a constant stress and at a constant temperature, that will be termed as the creep. Okay, now here we are going to use the first condition we are going to use is the constant temperature and the constant stress value. Now, whichever temperature we are going to use, whichever temperature we are going to use in this test, suppose that will depend on the melting point of that particular metal under the test. Okay, whichever melting point is there, for that melting point we are taking our experiment temperature zero point 0.4 times, for zero point 0.4 times the melting point of that particular metal. Okay, that will be our temperature value for conducting the this creep test. Are you getting this? And that stress values also will depend on, we are going to take the different stress values, and we are going to, sometimes we are going to check with the different temperature also, but generally the temperature taken in the test condition is zero point 0.4 times the melting point of that particular metal under the test. Okay, now, and this is the what is the meaning of the creep. And after understanding the what is the meaning of the creep, then how it is useful, why we are going to calculate the creep limit or creep strength of a particular material by conducting this test, there is a certain purpose. After knowing the creep behavior of a metal under different stress conditions and at different temperature conditions, here we can determine or we can understand up to which temperature or which material is suitable for higher temperature conditions, or simply you can say that we can determine the suitability of a particular metal for high temperature service conditions with some stresses acting on that material. For example, you can say that some different components are there. You can say that gas and steam turbines are there, then nuclear reactors are there, then jet engine components are there. These components are subjected to the high temperature service conditions along with some amount of distress. Then how much stress they can carry, that we can tell, means how much stress they can carry and at how much temperature they will sustain with that much stress, that we can determine by conducting the creep test on that material. So this is the purpose of this conducting the creep test, so that we can clearly understand which material is suitable for higher temperature conditions and how much stress it can withstand. Okay, this can be determined by this creep testing. Now there is one here some terms are there at the end of this experiment. You will end up with getting some values, like you can say that what is the creep strength of the material. Creep strength is also known as the creep limit of the material. Now what is the meaning of the creep strength, or you can say that the creep limit. Creep strength of the material is nothing but, you can say that, highest amount of the stress that material can withstand. Highest amount of the stress that material can withstand uh, for a given time and given temperature conditions. Okay, here how much amount of stress a particular material can carry at given temperature conditions and at given time conditions, that will be termed as the creep strength or creep limit of that particular material. Now, so these are some basic terms. What is the meaning of creep? Then what is the meaning of the creep strength? And why it is important to calculate or to determine the strength, or you can say that the creep behavior of a particular material. If you are aware about the creep behavior or creep limit of a particular material, then you can choose that application of that particular metal in the high temperature condition along with some amount of distress. Okay, for that you should conduct the creep test on that material, and you should find out the values of the creep limit, or you can say that the creep strength of that particular material. Okay, so this is the creep test, and it's related some important terms related to it. Then after this we will move towards some means we will move towards the actual test setup and how the experiment is conducted. Okay, now here you can see in the diagram here, this test setup is there. Now here at the exactly at the center you can see here specimen is fixed here, and here we are using some furnace arrangement. Okay, this is the furnace, and inside that furnace we are keeping that specimen. With the help of this furnace we can keep some constant temperature. Okay, here we are going to use this furnace to keep this temperature of that specimen at a particular value, and generally the value taken is 4.4 times the melting point of that metal. This is the furnace. Okay, it will helpful for maintaining a constant temperature. Then on this specimen we are going to apply a constant stress. Okay, creep test is conducted under by keeping temperature and stress constant. Okay, this you have to remember. Sometimes they may ask you these questions in the objectives. uh, Means which parameters are kept constant during the conduction of the creep test or while finding out the creep limit of a material. The stress value will be kept constant and temperature value will be kept constant. Okay, this temperature will be kept constant with the help of a furnace. Okay, and the stress will be kept constant by applying a constant load. Here weight is applied on that specimen. Okay, with the help of furnace, here we are maintaining a constant temperature value, and with the help of this load we are maintaining a a constant stress value. Okay, constant temperature and constant stress is maintained, and here one frame is used to support all this arrangement. This is supporting frame, you are seeing it, supporting frame, having one base is, this is the base, and with the help of one arrangement here we are applying the load on this specimen. Okay, now, and how the readings are taken or how the actual test is conducted, here we are going to keeping the temperature and stress value constant, and now at, by fixing some time or by taking some time interval, suppose 5 minutes, 10 minutes, like that, at each time, or 1 hour or 10 hour, like this we are keeping some time interval, and at that particular time interval, suppose 1 hour you have taken, after each 1 hour you have to take the readings related to the deformation. You have to take the readings related to the deformation in that material. Okay, deformation or strain which is occurring in that material, and that values are plotted. Okay, that values are plotted, and you are going to end with a one curve, by plotting the deformation, or you can say that the strain on y-axis, and on x-axis we are going to plot the time, and the curve which is obtained, that will be termed as a creep curve or deformation curve. Creep curve or deformation curve. Here in the first diagram, at the end of this creep test, you will get this kind of the curve. Okay, as time is passing away, we are taking at, suppose particular interval of time is fixed, and at that time we are taking the readings related to the deformation, or you can say that the creep strain we are measuring, and that is plotted on y-axis. On x-axis we are taking the time, and one curve is obtained. That curve is termed as the creep curve or deformation curve. Okay, now sometimes in examination they have simply asked this question to explain this creep curve. Just for 4 marks they have asked this question. Just they have asked to explain what is the meaning of the creep curve, and what are the different stages in the creep curve and factors affecting that creep curve. Okay, so this is the creep curve, this is the output which we are going to obtain. Okay, this creep curve at deformation, how much amount of deformation will be there according to the time, or as time is passing away, how much will be deformation in that particular specimen. And these readings are taken until that material or metal under the test, it will get fractured. It will get fractured after certain period of time. It may take one day, or it may take few days or few weeks, or you can say that few months. Sometimes you have to conduct this test for many years also to get the proper readings. You have to conduct this test until this fracture, this metal will get fractured. Okay, and that value you will get at the end here, amount of deformation when that material got fractured, and here you will get the time value, and your test will end, and you will end up with getting some, uh, at the end you will end up with getting the creep limit of that particular material or creep strength. Sometimes there is one more term, that is the creep rupture strength. What is the meaning of the creep rupture strength? Okay, simply the creep rupture strength is the highest amount of the stress that material can withstand without fracture. Highest amount of the stress that material can carry without fracture. Okay, so this is the value. Okay, how you are going to get that? We are conducting the same test at different stress values, different temperature values, and for each temperature value, and at each time we are means suppose we are selecting some particular temperature and one stress value, and for that we are conducting this test, and again we will take the another stress and another temperature value, and for that we will conduct this same test. It will take different time values. and at a particular stress value that where that material will fracture, or highest amount of the stress that material can withstand without rupture, that will be termed as its rupture strength, or it is also known as creep rupture strength. Okay, so this is the conduction of the creep test. Okay, simply I'll repeat the test procedure. The metal under the test will be prepared, that is the specimen will be taken. Now here, while taking this specimen, here you have to give it some shape to its cross section may be circular, or it may be a square, or a rectangular cross section will may be there. You can use any cross section, circular, rectangular, or square cross section you can use, and it is fixed in this arrangement. Then with the help of a furnace, some constant temperature is maintained here, and with the help of this some weights are there, weight arrangement is there. With help of that weight, we are applying the load, and we are giving it some stress in that metal. And now here we are keeping this temperature and this weight constant, that is temperature and stress will be constant. And as time is passing away, we are taking the readings related to the deformation occurring in that component or that material under the test. And one curve is plotted by taking the deformation against the time, or deformation is also termed as the creep strain against the time, and a curve is obtained, and that curve will be termed as the creep curve. Okay, that will be termed as the creep curve. And the this test will be completed when the fracture in that material will occur, and the stress value where that fracture will occur, or maximum amount of stress that material can withstand without the fracture or rupture, it will be termed as the creep rupture strength. Okay, then the next is the creep curve. Okay, this curve, now we have to explain, you have to explain this curve, or you have to understand this creep curve, and why there is certain, here you can find that some decrease in the you can say that the creep rate or deformation rate is very faster in this region than it is decreasing. Okay, in the AB region, A to B region, deformation rate is very fast. Then in B to C, deformation rate is decreasing. In C to D, again it decreased. And in D to E region, again the deformation rate is increased here. Okay, why this is occurring? That you have to explain why it is occurring. Okay, I'll explain it. Uh, Please wait for 1 minute. You can draw the diagram also. Okay, okay, this is the creep curve. Already I have explained this how this curve is obtained. Now here, this creep curve, you can find it from this diagram, or you can observe it that this creep curve is divided in three parts. Okay, it is divided in three parts. This is the first part. Wait. This is the first part, primary creep, secondary creep, and this is the tertiary creep. Okay, here, when suddenly we have applied the load. Okay, initially, when initially we have applied the load, then at that time, okay, when you have applied load initially, then instantaneous elastic deformation will be there. Okay, this is the instantaneous deformation. This part A to B is indicating the instantaneous deformation which is occurring when you have applied the load initially. Okay, and it is represented by this AB, instantaneous, you can say that instantaneous elastic deformation this AB region. Then from B to C, some primary or transient, it is also known as transient creep. Then from C to D, secondary creep or steady state creep is there. And finally, from D to E, tertiary or accelerated creep is there, which is indicated by this DE. Okay, I will repeat it again. From A to B, when you have applied load initially, instantaneous elastic deformation will occur in this AB region. And from B to C, primary creep will occur. This primary creep is also known as the transient creep. Then secondary creep will occur in this region C to D. The secondary creep is also known as steady state creep. And in this region D to E, tertiary creep or accelerated creep is there. Okay. Now, here the next point which you have to explain why here rate is decreasing, why in BC and CD region rate of deformation decreased, and why in DE region rate of deformation increases suddenly. That you have to explain. And the one more term you have to explain here is what is the meaning of this minimum creep rate. What is the meaning of this minimum creep rate? Okay, first I will explain these different stages why this deformation rate is lower. Now, before explaining that deformation, why deformation rate is lower or deformation rate is higher, first you should understand the factors which will increase or decrease the deformation rate. Now, whenever strain hardening is there, whenever strain hardening is more, at that time deformation decreases. And whenever higher temperatures are there, then deformation increases. Okay. Now, uh, in this particular region, higher temperatures in this sense, some softening or annealing of that material will occur. When strain hardening takes place, deformation decreases, and when annealing or softening occurs, then deformation increases. And in the region D to E, in the region D to E, softening of that material or annealing of that material will takes or it will occur. Due to that, in this DE region, deformation is at accelerated rate. And in this primary creep or transient creep BC region, here strain hardening of that material is more than the you can say that the annealing or softening. Okay, at each point there will be hardening and softening, strain hardening and softening of that material. But when hardening exceeds the softening, then this rate will decrease. In this primary creep, strain hardening is more than the softening. That's why rate of deformation decreases. And again here in CD region, hardening is more than the softening of that material. That's why here rate again decreases in this secondary creep or steady state creep. But in this third region DE, here softening of that material will be more than the hardening. That's why here the creep increases with the accelerated rate. Okay, that's why it is termed as accelerated creep region or tertiary creep region. Now, the in the CD region, here whichever creep is increasing, whichever amount of strain is increasing or deformation is increasing, it is almost at a constant rate. It is almost at a constant rate. So this region is selected and its slope is calculated. Its slope is calculated. This is simple formula for calculating the slope from a curve, and you will get this. Okay, you will get this formula for minimum creep rate. Okay, change in the strain, you can say that to the change in time, you can take particular this region only, and you will able to get the minimum creep rate value here. Okay, So in this way, this whichever creep curve is obtained during this creep test, it is divided in these regions: initial instantaneous elastic deformation, then primary creep, or it is also known as the transient creep, and secondary creep or steady state creep, and tertiary creep, or you can say that accelerated creep. Then why this secondary creep only selected to calculate minimum creep rate? Here the deformation rate is at a constant, somewhat constant rate, not exactly constant, but it is rate is minimum at that time. That's why it is selected. Deformation rate will be minimum here. That's why this region is selected, CD region, and slope is calculated, and you will get the minimum creep rate value here. Okay, so in this way, we are going to get the creep curve and different deformation values at different time intervals. Okay, so in this way this creep test is conducted. Now after this, this is the end of this creep test, and in the next few diagrams here, the what is the effect of the stress on the minimum, you can say that on the effect of the stress and effect of the temperature on the minimum creep rate. Then what is the effect of temperature on the creep curves? Okay, what is the effect of the temperature? What is the effect of the temperature? Here we are conducting the same experiment by at different temperatures by keeping the constant stress. Then we will get this kind of the curve, and from this curve it will be clear that this T1 is great, this T4 is greater than T3, T3 is greater than T2, and T2 is greater than T1. When lower temperature values we are using, or whenever you are using the higher temperature values, then more amount of deformation or creep strain will be there with lesser time. Okay, with lesser time. And that is that you can understand with this curve here. We have taken the different temperature values and we have conducted the same creep test lots of times by keeping stress value constant. Okay, stress value we are keeping constant, and we are conducting the same test at by taking different temperature values, and we are ending with this curve. And this curve will tell you that whenever you are using the higher temperature values, the deformation or creep strain will occur at a faster rate, which means with minimum time more deformation can be obtained. The next curve is exactly reverse here. Here we are understanding the what is the effect of the stress by we are conducting the same creep test by keeping or by using a constant temperature value, and we are conducting the test by changing the stress values. And same test is conducted, and we will get the what is the effect of the stress on the creep curve, or what is the effect of the stress values or different stress values on the deformation. The higher the amount of the stress, higher the amount of the stress, more will be the deformation within lesser time. Okay, within lesser time you will get the more amount of deformation when stress is more. Okay, when stress is more deformation can be achieved with lesser time. Same here in case of the temperature. More deformation can be obtained with lesser time with higher temperatures. Simply we can combine this. Whenever we are using higher temperatures or higher stress values, higher will be the deformation or creep strain in the material with the lesser time. With the lesser time. Okay. So these two curves you have to explain. What is this is the effect of the temperature on the creep curve at constant stress. And this curve is for representing the effect of the stress on the creep curves. This is the effect of the stress on the creep curves at constant temperatures. And okay, this is the what is the effect on the minimum creep rate. Okay, on the minimum creep rate also. Whenever your combined effect of stress and temperature. Okay, here what is with higher temperature values? Here we have used three different temperatures: 150 degrees Celsius, 200 degrees Celsius, and 250 degrees Celsius. You can write here any values in the increasing order. Okay, this is just a example of the test, and here minimum creep rate is plotted on x-axis, and on a y-axis stress is taken. In simple words, you can say that when higher amount of stress is there, when higher temperature is used, you can get the minimum or creep rate will be more when temperature is more. Creep rate, you can achieve the creep rate values with the higher temperature ranges. Okay, whenever you are using the higher temperature ranges, or due to the higher temperature with the minimum stress also, you will get the desired creep rate, or whichever minimum creep rate is there. When temperature is increased with lower stress values, whenever you are increasing the temperature with lower stress values, you can achieve that creep rate. Okay, so this is the effect of stress and temperature on the minimum creep rate. This is the creep curve. Then effect of temperature on the creep curves, then effect of stress on the creep curves. Okay, while when you are studying the effect of stress on the creep curve, at that time you have to keep the temperature constant, and when you are studying the effect of temperature on the creep curve, at that time you have to keep stress value constant. Okay, then the last point from this creep test is the which type of fracture is will occur in that material. Okay, now which type of fracture will occur in that material? And that is the okay. To understand this, now here you have to understand some concepts here, so that you can easily remember that which type of crack will occur. Now, formation of this crack here in this first diagram, this diagram you can see that whichever crack is formed is transgranular, or it is also known as transcrystalline fracture. Okay, this is transgranular or transcrystalline fracture. Why it is termed as transgranular or transcrystalline? Because the crack formed is through the grains. Okay, this shape, these are the grains. Okay, this is the grain boundary. Whichever darker portion is visible, that is, this is the grain boundary. All these are grain boundaries, and this white portion is grains. Whenever crack formed, it moves through the grains. This type of crack is termed as transgranular crack or transgranular fracture. And whenever crack is forming along the boundary, exactly through these grain boundaries, that crack will form and propagate, that will be termed as intergranular or intercrystalline fracture. Intergranular or intercrystalline. Intergranular, it will move through the grain boundaries or along the grain boundaries, and transgranular, it will move through the grain. It will move through the grain. Okay, crack which moves through the grain, it is transgranular, and which moves along the grain boundaries, it is intergranular crack or fracture. And now, when this type of fractures will occur, okay, to understand which type of crack will form at low temperature and which type of crack will occur at the high temperatures, you should understand few concepts here. That concepts are like this: whenever temperature is low, then grain boundaries, when working temperature is low, then this grain boundary will be more stronger. Grain boundaries are stronger than these grains, and at higher temperatures, okay, at higher temperatures, grains are stronger. Grains are stronger. Okay, I will repeat it. When low temperature working temperature is low, then grain boundaries are stronger as compared to the grains. And when working temperature is very high, then these grain boundaries are weaker than the grains because they come in contact with the higher temperatures. And at a particular temperature, if there is particular temperature value, at that temperature value, the strength of the grain boundary and grain is same, that temperature is known as equicohesive temperature. Okay, temperature at which strength of grain boundary and strength of the grain is equal, that temperature is termed as equicohesive temperature. And whenever the working temperature of that component is less than the equicohesive temperature, then this transgranular fracture will occur. Whenever working temperature is less than equicohesive temperature, then what will happen here? Grain will be having means lesser, grain will be weaker, grains will be weaker. That's why when temperature is less than equicohesive temperature, then fracture will be formed uh, through the grains, that is transgranular fracture. And whenever temperature is higher than equicohesive temperature, then at that time what will happen, fracture will form along the grain boundaries where grains are stronger. Okay, that type of fracture will be termed as intergranular fracture. I will repeat it. Whenever temperature, working temperature is less than equicohesive temperature, then fracture formed will be transgranular or transcrystalline. And whenever working temperature is more than the equicohesive temperature, then cracks formed will be intergranular or intercrystalline. Okay, so this is the fracture behavior. These two types of the fractures will occur in the creep test. That this also you have to explain in the creep test. Okay, so in this way we have conducted this, means we have understood what is the meaning of creep, then why we are performing this creep test, what is the meaning of creep limit, then what is the meaning of creep strength, then what is the meaning of, you can say that, creep strength. Then you have also studied the test procedure, test setup, and then we have understood what is the meaning of creep curve, various stages in that creep curve, factors affecting that creep curve, or what is the effect of changing temperature, or what is the effect of changing stress values on the creep rate, or simply you can say that the deformation rate or creep strain. And after that, which type of the fractures can occur in this creep test that we have studied. So you have to explain it stepwise. Okay, in this way we have concluded this part, the creep test. Okay, if you are having any query, you can ask me, uh, whichever query may be there, you can ask me related to this creep test that I will try to clear here only. And if you are not having any query, put that also in the chat box, so that I will stop the session here only. If you are having any query, put that in the chat box. And if all points are clear, I will stop this session here only. And in next session, we will discuss related to the hardness testing and fatigue testing. Okay, only two tests are remaining, means remained, that we are going to discuss in next, means we will finish that in the next two sessions. Okay, please provide me reply if you have understood. Then you can put that in the chat box. Otherwise, okay, if all points are clear, okay, if you are not having any questions or doubts, I will stop this session here only. Thank you for attending this session. Okay, thank you.